Alright, let's go. Number 10. The Codex Xolotl. In the years following the fall of Tenochtitlan, as Spanish friars cataloged the ruins of an empire they had helped dismantle, a group of indigenous scribes in the Valley of Mexico began drawing. Around 1542, working on sheets of amate paper hammered from the inner bark of the wild fig tree, they produced something that would later be known as the Codex Xolotl. It was not a book in any European sense. It was a map of memory. The Codex documents the history and geography of the Valley of Mexico across centuries of migration, settlement, and dynastic succession. It traces the arrival of the Chichimec peoples under the leader Xolotl. It records the founding of cities. It names the lakes, the mountains, the boundaries between territories. And it does all of this simultaneously on the same surface, layering genealogy over topography over political history in a way that no European map of the period attempted. The visual language is precise. Rendered in earthy reds, blacks, and ochres pulled from mineral pigments, the Codex uses hieroglyphic footprints to trace migration routes across the painted landscape. A line of small painted feet moves across mountains, around lakes, into the founding places of cities. Each footprint is a generation. Each cluster of footprints is a journey that took decades. Place names appear as glyphs anchored to the locations they describe. Genealogies branch upward from the rulers who founded each settlement, connecting the political present of 1542 to a deep ancestral past stretching back hundreds of years. This was not improvisation. This was not a desperate attempt to imitate Spanish cartography under colonial pressure. The Codex Xolotl represents a fully developed indigenous cartographic tradition that existed long before any European set foot in the Americas. The conventions, the symbol system, the integration of time and space on a single surface, all of it predates contact. What survives on the amate paper is the late expression of a discipline that had been refined for centuries within the Nahua intellectual world. But here's where the Codex becomes something more than a beautiful artifact. By the time it was completed, the world it documented was already being erased. Spanish colonization had begun dismantling the political structures the Codex recorded. Cities were being renamed. Populations were being relocated, converted, decimated by disease. The lakes of the Valley of Mexico were beginning their long, slow drainage that would eventually leave the basin almost dry. The places named in earthy red and black on the fig bark were, in many cases, already gone or in the process of vanishing. What the Codex preserves, then, is not a working map of a living territory. It is a map of a territory in the act of being destroyed. The scribes who painted those hieroglyphic footprints were recording routes that their grandchildren would no longer be able to walk. They were naming cities that would soon exist only as Spanish renamed shells of themselves. They were documenting a world they knew was disappearing beneath them, and they were doing it in the only cartographic language that could hold that world intact. The implications extend further than a single document. The Codex Xolotl is one of the few surviving witnesses to a sophisticated mapping tradition that flourished across Mesoamerica for centuries before European contact. How many similar codices existed? How many were burned by friars convinced they contained demonic content? How many crumbled to dust in the humid climate of central Mexico while Spanish administrators ignored them? The number is unknowable. What we have is a fragment of a fragment, a single voice from a chorus that was silenced. The amate paper still survives. The footprints still march across the painted valley, and the cities they lead to, many of them, exist now only in the pigments a scribe ground by hand nearly 5 centuries ago. Number 9. The Lascaux Star Map. In 1940, 4 teenagers and a dog wandered into a hole in the ground in southwestern France and walked into a gallery that had been sealed in darkness for 17,000 years. The walls of the Lascaux caves were covered in bulls, horses, stags, and aurochs, rendered in black manganese and red ochre pigment on rough limestone. The figures were so vivid, so anatomically precise, that the first researchers to enter the chamber initially refused to believe the paintings were Paleolithic. They looked too modern, too deliberate, too aware. But the animals were only the first layer of the mystery. Above the shoulder of the great black bull in the Hall of the Bulls, a cluster of 6 dots floats against the limestone. They are small, easy to miss. For decades, they were dismissed as decorative flourishes or accidental smudges left by a painter cleaning a brush. In 2000, German researcher Michael Rappengluck, then at the University of Munich, published an analysis proposing something that reframed the entire chamber. The 6 dots above the bull, he argued, were the Pleiades, the star cluster that has anchored human navigation, mythology, and agricultural calendars across every continent for as long as written history exists. Another arrangement of dots elsewhere in the cave, he proposed, corresponded to the summer triangle, the 3 bright stars Vega, Deneb, and Altair that dominate the northern summer sky. If Rappengluck was correct, the implications collapsed the timeline of human cognition. 17,000 years ago, before agriculture, before pottery, before the wheel, before any system of writing that has ever been recovered, someone walked into a cave in what is now the Dordogne Valley, carrying a torch and a small bowl of crushed manganese, and they painted the sky onto the stone. They did not paint it as decoration. They painted it in relationship to the animals. The bull and the cluster sit together, the hunter on earth and the hunter in the heavens. A map of where the herds moved, and a map of where the stars moved, rendered in the same pigment, on the same wall, by the same hand. The paintings predate the earliest known written language by over 12,000 years. They predate the first cities by 10,000. They predate the agricultural revolution itself, and the conditions of their making are almost impossible to reconstruct. The chamber has no natural light. Whoever painted the bull and the dots above it worked by the flickering of animal fat lamps and pine torches, their shadows lurching across the limestone as they moved. The Pleiades cannot be seen inside a cave. The summer triangle cannot be seen inside a cave. Whatever was being mapped existed only in memory, carried from the open sky above the valley, down through narrow passages of stone, and committed to the wall from recollection alone. This is the part that resists comfortable explanation. To represent a constellation on a wall, you must first conceive of the sky as a thing that can be represented. You must understand that the points of light overhead form patterns, that those patterns persist, that they can be abstracted from their location and transferred onto another surface. You must possess, in other words, the cognitive architecture of a cartographer. 17,000 years before the first surveyor's chain, before the first geometer's compass, before the first scribe pressed reed into wet clay, someone in a French cave was already performing the fundamental act of mapping, taking the world that exists and pinning it to a surface that can be carried, returned to, taught from. The dots are still there. The bull is still there. The torch that lit them has been gone for 170 centuries, and the sky they recorded still wheels overhead, mostly unchanged, waiting for someone to look up and recognize what was already known. Number 8. The Saint-Bélec slab. In 1900, a French archaeologist named Paul du Châtelier was excavating a Bronze Age burial mound in Finistère, on the western edge of Brittany, when he uncovered a slab of stone that had been deliberately broken and reused as part of a tomb wall. The slab was roughly 2 meters long, bluish-gray, carved from local schist, and covered in a network of engraved lines, circles, and squares so dense that it resembled a piece of abstract art. Du Châtelier catalogued it, noted its strangeness, and moved on. The slab was transported to a private collection, then eventually to a museum storeroom in the Château de Carneuse, where it was placed in a cellar alongside other objects deemed too obscure to display. There it sat for 114 years. In 2014, a team of researchers searching through the chateau's basement collections rediscovered it. They knew immediately they were looking at something that had been catastrophically misunderstood. By 2021, after years of three-dimensional scanning, geological analysis, and comparison with regional topography, the team published their conclusion. The Saint-Bélec slab was a map, not a symbolic chart, not a decorative panel, a topographic map of a real territory, carved sometime between 1900 and 1640 BCE, making it the oldest known three-dimensional map in Europe. The numbers behind that claim are what make this entry impossible to dismiss. The slab's surface had been deliberately sculpted into a curved, raised landscape, a physical relief surface, not a flat plane. The engraved lines on that surface form a branching network that researchers identified as a river system. The circles and squares are settlements, enclosures, and burial mounds. When the team compared the slab's features to the modern topography of Western Brittany, they found a match. An 18-mile wide stretch of territory along the River Odette, with its tributaries and ridgelines, aligns with the slab's engravings at approximately 80% accuracy. 80%. From a stone carved nearly 4,000 years ago by people with no instruments, no written language, no aerial perspective, and no theoretical framework for cartography that has survived to be studied. But here's where the standard understanding of Bronze Age Europe begins to collapse. The Saint-Bélec slab is not a sketch. It is not a memory aid scratched into rock by a wandering herdsman. It is a deliberate, sculpted, three-dimensional rendering of a specific 18-mile wide territory, executed with enough precision that modern researchers using satellite data and digital elevation models can overlay it onto the actual landscape and watch the rivers line up. Whoever made it understood that a piece of land could be compressed, scaled, and represented from above. They understood relief. They understood proportion. They understood that a single stone could stand in for a kingdom. The implications are staggering. A society capable of producing this slab in 1900 BCE was a society with political boundaries worth mapping, territorial claims worth recording, and an elite class sophisticated enough to commission the recording. The slab may have functioned as a legal document, a physical assertion of who controlled which river valley, which ridge, which settlement. It may have been a tool of power, and the fact that it was eventually broken and entombed within a burial mound suggests that the power it represented ended violently. Someone shattered the map. Someone buried it. The territory it described continued to exist, but the political order that produced it was erased so completely that we cannot name a single person who lived under it. The people who carved the Saint-Bélec slab are gone. Their language is gone. Their kings, their priests, their borders, their wars, gone. What remains is a sculpted piece of schist that sat in a French cellar for over a century, while archaeologists walked past it, unaware that they were stepping around the oldest map of Europe ever found. The river it depicts still flows. The ridges it sculpts still rise. The civilization that mapped them left nothing else behind. Nothing but the stone. Number 7. The Çatalhöyük wall map and the village beneath the volcano. In 1963, archaeologist James Mellart, excavating the Neolithic settlement of Çatalhöyük in south-central Turkey, uncovered a wall painting that would force a fundamental reassessment of when human beings began to map the world. The painting had been preserved beneath layers of plaster and accumulated debris for approximately 8,200 years. When Mellart cleaned the surface and saw what was beneath, he reported something extraordinary. Rows of rectangular structures, arranged in tight clusters, sat beneath the looming shape of a mountain. The mountain was erupting. Streams and dots radiated outward from its twin peaks, raining down across the painted surface. Mellart identified the image as a town plan. Specifically, he proposed it depicted Çatalhöyük itself, viewed from above, with the volcano Hasan Dağ erupting behind it. If his interpretation is correct, the painting is the oldest known map in human history. It predates Mesopotamian cuneiform by over 3,000 years. It predates the invention of writing entirely. It predates the wheel. It predates the domestication of the horse. A community of Neolithic farmers in what is now central Anatolia rendered their settlement and its geological surroundings in pigment on plaster before any human anywhere had developed a system of written symbols. The painting itself is roughly 3 meters wide, executed in red ochre on a white plaster ground. The rectangles are arranged in the dense, honeycomb-like pattern that characterized Çatalhöyük itself, a settlement where houses were built directly against one another with no streets between them, entered through openings in the roof. The community housed an estimated 5,000 to 8,000 people at its peak, making it one of the largest Neolithic settlements ever excavated. Above the rectangles, the volcano dominates the upper register of the composition, twin peaks streaming with what appear to be pyroclastic flows or falling ash. Hasan Dağ is approximately 130 kilometers from the site. It is a real volcano. Geological surveys have confirmed it was active during the period of Çatalhöyük's occupation. But here's where the standard interpretation falls apart. In 2006, art historian Stephanie Mies published a paper in the journal Anatolian Studies, arguing that the painting is not a map at all. The rectangles she proposed are not houses. They are the geometric markings of a leopard skin, a recurring motif in Çatalhöyük's art and ritual life. The volcano, she suggested, is not Hasan Dağ. It is the leopard's head, rendered in the same abstract style as the body. The dots and streams are not pyroclastic flows. They are the spots of a leopard's pelt, falling away from the central figure in a decorative cascade. The debate has not been resolved. Subsequent geological studies, including a 2014 analysis published in PLOS 1, identified zircon crystals in volcanic deposits near Çatalhöyük, dated to within decades of the painting's likely creation, confirming that the inhabitants would have witnessed Hasan Dağ erupt within living memory. The volcanic interpretation gained ground. But Mies's reading remains scholarly possible, and other researchers have proposed that the image might be both, a leopard skin and a landscape, a map and a ritual object simultaneously. The categories we use to separate cartography from cosmology imposed by modern minds on a Neolithic worldview that did not divide the world that way. This is what makes the Çatalhöyük painting particularly unsettling. We cannot be certain what we are looking at. The people who made it left no writing to explain themselves. They left no key, no legend, no second image to compare. They painted something on a wall 8,200 years ago, and then they vanished. And what they meant by it has dissolved into the same geological silence that swallowed their language and their names. If the painting is a map, it is evidence that cartographic thinking existed in human minds millennia before we believed it could. If it is not a map, then somewhere in the archaeological record, there may be maps we have already found and failed to recognize, mistaken for decoration, mistaken for ritual, mistaken for nothing at all. The plaster is still there, in a museum in Ankara, still red, still waiting for us to understand what the people who painted it were trying to say. Number 6. The Bedolina petroglyph and the impossible perspective of the Bronze Age mind. In the Alpine valley of Val Camonica in northern Italy, on a weathered face of glacially polished sandstone, someone in approximately 1000 BCE stood with a stone tool in their hand and began pecking lines into rock. They were not drawing a god. They were not drawing an animal. They were not drawing a hunt. They were drawing the world from above. The Bedolina petroglyph stretches across roughly 4.3 by 2.4 meters of gray alpine stone. Its surface is covered in shallow pecked lines forming geometric patterns that, when first encountered, resemble abstract decoration. Rectangles tiled in rows, connecting paths, small dots clustered inside the geometric shapes. Human figures scattered across the composition. For decades, the carvings were cataloged as ritual art, the kind of symbolic ornamentation that Bronze Age cultures left across rock faces from Scandinavia to the Sahara. Then someone tilted their head. The rectangles were fields. The dots inside them were crops or grain stores. The connecting lines were paths between cultivated plots. The small structures clustered along the network were houses. The Bedolina petroglyph wasn't decoration. It was a map, a topographic representation of an owl. Agricultural landscape rendered from a perspective no human in 1000 BCE could ever have actually occupied. The Comuni people, an Iron Age population who inhabited Val Camonica for centuries and left behind one of the densest concentrations of rock art in Europe, had carved a bird's-eye view of their own territory into stone 1,000 years before the Greeks formalized cartography as a discipline. The implications are staggering. To draw a landscape from above requires a cognitive operation that has nothing to do with vision. No member of the Comuni culture had ever seen their fields from the sky. They had never climbed high enough to look down on the full pattern of their cultivation. They possessed no aerial vantage point, no elevated platform, no method of observation that would have allowed them to confirm what their valley actually looked like from 500 meters up. And yet, they drew it. They drew it accurately enough that modern researchers comparing the petroglyph to the surrounding terrain have been able to identify the patterns of Iron Age field systems preserved in the carving. The Comuni were performing in their minds an act of spatial abstraction so sophisticated that we still teach it in geography classrooms today. They were mentally lifting themselves above the world and translating three-dimensional space into a two-dimensional symbolic system. This is not how prehistoric cognition is supposed to work. The standard developmental model of human cartography places aerial perspective mapping somewhere in the classical era, an outgrowth of mathematics, astronomy, and the kind of abstract geometric thinking that civilizations are supposed to develop only after centuries of urbanization. The Bedolina petroglyph predates all of that. It was carved by a culture that left no written language, no monumental architecture, no centralized state. They were farmers and herders in an alpine valley. And they were also cartographers operating at a level of conceptual sophistication that the conventional timeline of human development has no framework to accommodate. What makes the Bedolina petroglyph particularly unsettling is that it is not alone. Similar topographic carvings have been identified at other rock art sites across Val Camonica, suggesting that aerial perspective mapping was not a one-time anomaly produced by a single brilliant mind, but a tradition. A shared cognitive technology passed between generations of Comuni rock carvers. Somewhere in that valley, 1,000 years before Christ, there were people teaching other people how to see their world from above. The pedagogy of that transmission, the language they used, the names they gave to the concept of representing space symbolically, all of it is gone. What remains is the rock. And the rock raises a question that the next several entries will only sharpen. If a culture without writing, without cities, without any of the markers we associate with advanced civilization, could produce a map drawn from an impossible perspective, what does that tell us about every other prehistoric culture whose stone-carved knowledge we have dismissed as decoration? How many maps are sitting on cave walls and cliff faces right now, mislabeled as ornament, waiting for someone to tilt their head? The Comuni saw their valley from the sky without ever leaving the ground. And someone else, 1,500 years later and a continent away, would draw a land bridge that had been underwater for 10,000 years. Number 5. The Haji Ahmed map. In 1559, in the workshops of Ottoman Constantinople, a cartographer working under the name Haji Ahmed produced a world map unlike anything that should have existed in the 16th century. The map was rendered as a cortiform projection, a heart-shaped depiction of the entire known world, densely illustrated with Arabic script. ornamented with gold leaf accents and inscribed with coastlines drawn at a level of detail that exceeded most European cartography of the same decade. It was a masterwork of Islamic Renaissance mapmaking. It was also impossible. The impossibility sits in the northwestern corner of the map, in a region that should have been a matter of speculation, blank parchment, or guesswork. Haji Ahmed drew Siberia. He drew Alaska, and he drew them connected. A solid land bridge stretches across the map between the Asian and North American continents, joining the two landmasses where today the Bering Strait separates them by 82 kilometers of cold ocean. That land bridge is not a cartographic invention. It is not a hopeful guess. It is not an artistic flourish to fill empty space. Geologists call it Beringia, and it existed. It existed during the last glacial maximum, when sea levels were 120 meters lower than today, and the exposed continental shelf formed a corridor wide enough for mammoths, caribou, and the first human populations to walk from Asia into the Americas. Beringia disappeared approximately 10,000 years before Haji Ahmed lifted his pen. The numbers are worth holding in the mind. The Bering land bridge was submerged by rising seas at the end of the Pleistocene, around 8000 BCE. By the time Ottoman scholars were assembling their world atlas in 1559, the corridor had been beneath saltwater for 10 millennia. No living human had seen it. No oral tradition in any literate civilization recorded it. The peoples who had crossed it were the ancestors of the indigenous Americas, and their migration predated writing by thousands of years. The geological feature Haji Ahmed drew had vanished before the invention of the wheel, before the first city, before the first written word. And yet, there it is on the parchment, rendered in Arabic script and gold leaf, as confidently as if the cartographer had walked it himself. But here's where the conventional explanations begin to fracture. The standard response from skeptical historians is that 16th century mapmakers frequently connected Asia and North America because they did not yet understand the two were separated. The Bering Strait was not formally documented by European explorers until Vitus Bering's voyage in 1728, nearly 2 centuries after Haji Ahmed's map. So a Renaissance cartographer assuming continuity between the two landmasses is not, on its own, miraculous. It could be ignorance dressed up as accuracy. Except the Haji Ahmed map does not depict ignorant continuity. It depicts a specific, narrow corridor at a specific latitude with the rough shape and orientation that matches the reconstructed geography of Beringia, as understood by modern paleogeographers. The land bridge on the map is not Asia and North America fused into a single supercontinent. It is a constricted passage at the correct location, with the correct general form, connecting two otherwise distinct landmasses whose surrounding coastlines are drawn with recognizable fidelity. The implications are staggering. Either Haji Ahmed and the Ottoman cartographic tradition guessed correctly about a geological feature that had been gone for 10,000 years, and guessed correctly about its location, its shape, and its relationship to the surrounding continents. Or the map preserves information that traveled across millennia from a source we cannot identify, through channels we cannot reconstruct, into a workshop in 16th century Constantinople, where a scholar drew it without knowing what he was drawing. Haji Ahmed himself is a phantom. Some historians question whether the name represents an actual person or a pseudonym adopted by a European cartographer working under Ottoman cover to evade Inquisition restrictions. The map's source materials are unknown. The references it draws from, the older charts, the inherited geography, the lineage of knowledge that flowed into a heart-shaped projection in 1559, have not survived. What survives is the artifact, a 16th century map showing a land bridge that vanished at the end of the Ice Age, drawn with enough precision that modern observers can identify it for what it is. The pattern is becoming difficult to dismiss. Prehistoric peoples mapping their valleys from above. Renaissance cartographers depicting geography that predates civilization. The information is moving in directions it should not be able to move. Across timescales it should not be able to cross. And the Haji Ahmed map is not the only Renaissance document that performs this impossible trick. The same century produced another heart-shaped projection, drawn nearly 30 years earlier, that depicts a continent no European had yet seen. Number 4. The Oronce Fine map. In 1531, a French mathematician named Oronce Fine published a world map unlike anything Europe had produced before. Fine was not a sailor. He had never crossed an ocean. He was a professor at the Collège Royal in Paris, a man who calculated planetary positions and corrected errors in classical geometry. He worked from manuscripts, not from coastlines. And yet, the map he produced in that year contains features that should not have been within reach of any scholar working in a Paris study in the early 16th century. The projection itself is startling before you even examine the geography. Fine rendered the world in a cordiform layout, a heart-shaped projection, with the continents bending and curving across the page as if the earth had been peeled and pressed flat by a hand that knew exactly where to make the cuts. Printed in black and red ink, surrounded by decorative borders and ornate Latin script, the map reads more like a devotional object than a navigational document. Sea monsters coil in the oceans. Windheads blow from the corners. The whole composition has the precision of a mathematical proof rendered in ink. At the bottom of the map, occupying the southern pole, sits a vast continent labeled Terra Australis. This is where the trouble begins. Terra Australis was not a discovery. It was a hypothesis. Greek philosophers had argued for 2,000 years that a southern continent must exist to balance the land masses of the north, and cartographers had been sketching speculative outlines onto the bottom of their maps for generations. Skeptics point to this immediately, and they are not wrong. A southern continent on a 1531 map proves nothing on its own. Fine was working in a long tradition of philosophical geography that placed something at the pole because something had to be there. But the Terra Australis that Fine drew is not a vague philosophical placeholder. It has structure. It has rivers running inland from the coast. It has mountain ranges in specific locations. It has coastlines that bend and inlet and curve in ways that mirror the actual shape of Antarctica as it exists beneath 2 kilometers of ice. The center of the continent, where Fine placed his mountains, corresponds roughly to the position of the Transantarctic Range. The coastal indentations align in several places with bays that modern surveys have mapped only in the last 70 years. The pole itself sits at the geographic center of the landmass, exactly where it should. Antarctica was not officially sighted until 1820. The first reliable maps of its true coastline were not produced until the 20th century. Subglacial topography was not surveyed until the era of seismic and radar imaging. Fine was working 300 years before any European set eyes on the continent, and 400 years before anyone knew what its bedrock looked like. The mainstream explanation is that the resemblance is coincidence, layered over speculation. Fine drew a continent because tradition demanded one. He added mountains and rivers because all continents have them. He drew coastlines because something had to enclose the land. The fact that some of those features approximate Antarctic reality is, in this reading, a statistical inevitability. Draw enough imaginary continents, and one of them will eventually look like something real. The numbers do not entirely support that comfort. The alignment is not universal. Large sections of Fine's Terra Australis are obvious invention, but the segments that do match are not minor. They are specific bays in specific locations at specific latitudes, and they appear on a map drawn by a man who had no instruments capable of measuring the southern polar coastline, and no source material that should have contained it. What makes the Oronce Fine map particularly unsettling is not that it depicts Antarctica. It is that it depicts an Antarctica with internal geography. Rivers and mountains are features of an ice-free continent. They are what you would draw if you were copying a source that showed the land before it was buried. Fine was a mathematician, not a mystic. He worked from documents. He believed those documents were accurate enough to commit to print under his own name and reputation. Where his sources came from, he never said. Whatever they were, they have not survived. Only the map remains, printed in black and red, heart-shaped, with a southern continent that contains too many rivers and too many mountains for a place no European had ever seen. Number 3. The Buache Map. In 1737, a French geographer named Philippe Buache de la Neuville published a map of the southern polar region that should not have been possible. He had never traveled to Antarctica. No one had. The continent would not be officially sighted for another 83 years. The seas south of the Antarctic Circle were, in 1737, a blank space on every reliable chart in Europe, a region of rumor and speculation where cartographers drew dragons or simply left the parchment empty. Buache did not leave it empty. He drew a continent, and not the speculative blob of Terra Australis that had drifted across European maps for 2 centuries. He drew something specific, something architectural, something that, by every standard of 18th century knowledge, he had no way of knowing. The map is rendered in pale blues and faded yellows, the colors of a polite drawing room atlas. Intricate latitude lines fan across the southern hemisphere in delicate arcs. Hand-lettered French annotations curl around the coastlines in the elegant copperplate script of the Enlightenment. It is a beautiful document. It is also, by any reasonable measure, impossible. Buache's Antarctica is not a single landmass. It is two distinct continental bodies separated by a waterway that cuts through the heart of the polar region, dividing the continent into eastern and western sections. He drew this division with confidence. He labeled it. He placed it in the precise geographic position, where, beneath 2 miles of ice, that division actually exists. The Antarctic continent we know today appears, from satellite imagery and surface observation, to be a single unified landmass. It is not. Beneath the ice sheet, the bedrock of Antarctica is divided into 2 major geological provinces, East Antarctica and West Antarctica, separated by a vast subglacial trench system that runs roughly along the line of the Transantarctic Mountains. If the ice were removed, the continent would resolve into 2 landmasses with a waterway between them. Exactly what Buache drew. This subglacial geography was not confirmed until the 20th century. Seismic surveys conducted across decades of Antarctic expeditions, using shock waves to penetrate the ice and map the bedrock beneath, gradually revealed what lay under the white surface. The work was painstaking. It required equipment that did not exist in 1737, technology that would not exist for another 200 years, and an entire scientific discipline, geophysics, that had not yet been invented. Buache's map predates the confirmation of its accuracy by nearly 250 years. The numbers compress into something difficult to hold. A French geographer working in a Paris studio with quill and ink, drawing a feature of the Earth's crust that lies beneath 2 kilometers of compressed glacial ice, on a continent no European had ever seen, with an accuracy that would not be verified until seismic technology developed in the second half of the 20th century. The interval between drawing and confirmation spans the entire Industrial Revolution, 2 world wars, and the invention of the airplane, the radio, and the computer. But here's where the standard explanation strains to its breaking point. Defenders of conventional cartographic history argue that Buache was working from theoretical models, that he speculated about a divided southern continent based on symmetry arguments, on the idea that the southern hemisphere must mirror the northern. It is a reasonable defense. It is also insufficient. Buache did not draw a generic divided continent. He drew the division in the correct location, oriented along the correct axis, with the correct general shape. Speculation does not produce geography that matches seismic data taken 2.5 centuries later. Speculation produces guesses. Buache produced a map. He claimed, as Piri Reis had claimed, that his work was based on older sources. Maps he had access to in the French royal collections. Documents that predated the Renaissance. Charts whose origins he could not fully trace. The originals, in nearly every case, have vanished. What remains is the copy, the derivative, the echo of something earlier, and the disturbing precision of what that echo preserves. The pattern is consistent, a continent drawn before its discovery, a geological feature recorded before the technology existed to detect it. A French geographer in 1737 sketching the bedrock of a frozen world he would never see, working from sources no one can now identify, producing a document whose accuracy would wait 2.5 centuries for instruments capable of confirming it. The map is still there. Pale blue and faded yellow, latitude lines fanning across the southern hemisphere, French script curling around coastlines that no one in 1737 had any business knowing existed. Number 2. The Zeno map. In 1558, a Venetian nobleman named Niccolo Zeno the Younger published a small book containing letters and a map he claimed had been languishing in his family's archives for nearly 2 centuries. The documents, he asserted, were the work of his ancestors, the brothers Niccolo and Antonio Zeno, who in 1380 had been blown off course in the North Atlantic and spent years navigating a labyrinth of islands no Venetian had ever seen. The map that accompanied the letters was unlike anything in the European cartographic tradition. It showed Greenland, it showed Iceland, and it showed lands that have no place on any modern chart of the world. The map itself is a quiet object, printed in muted sepia ink on aged paper, decorated with sea monsters coiling through the gray North Atlantic and wine compass roses radiating across empty ocean. It has the somber restraint of a document that does not need to shout. The coastlines are drawn with the confidence of direct observation. Latitudes are marked. Settlements are named. The northern world is rendered with a specificity that should not have been possible from a Venetian study in 1558. And then there are the islands that should not exist. Friesland appears as a substantial landmass south of Iceland, complete with bays, harbors, and inland features. Estatoland sits to the west, suggesting territory that would later be identified with the coasts of North America. Neither island exists. No expedition has ever found them. No sonar survey has located their submerged remains. They are, by every measurable standard, phantoms. Yet for nearly 200 years after the map's publication, European cartographers copied Friesland and Estatoland onto their own charts. Mercator included them. Ortelius included them. Sailors searched for them. The phantoms persisted in the Atlantic imagination until the 18th century, when better surveys finally erased them from the record. But here's where the standard explanation falls apart. The straightforward reading of the Zeno map is that it is a Renaissance hoax. Scholars have long argued that Niccolo Zeno the Younger fabricated the documents to inflate his family's prestige, cobbling together rumors, older maps, and pure invention into a romantic tale of medieval Venetian exploration. The case is strong. Friesland and Estatoland are almost certainly inventions. The narrative in the accompanying letters contains chronological impossibilities. The map's projection borrows from 16th century conventions that did not exist in 1380. Most working historians of cartography consider the matter closed. The Zeno map is a forgery dressed in the costume of antiquity. And yet, the map shows Greenland with no ice cap. The coastline of Greenland on the Zeno map is rendered as if the island were a habitable landmass with rivers, bays, and mountains visible from sea level. There is no ice sheet. There is no white interior. There is no acknowledgement that 90% of the island is, in the present epoch, buried beneath 2 kilometers of glacial ice. The Greenland of the Zeno map is the Greenland of a warmer world. This single detail is what keeps the document alive in conversations it should have left long ago. Because beneath Greenland's ice sheet, there is land. There are mountain ranges. There are river valleys carved by water that has not flowed in tens of thousands of years. Modern radar surveys have revealed an entire subglacial topography that nobody in the 16th century had any conceivable means of observing. The fjord systems shown along the Zeno map's Greenland coast bear an uncomfortable resemblance to the contours that ice-penetrating radar has confirmed beneath the modern ice. The implications fork in two directions, and neither is comfortable. The first possibility is the one most scholars accept. The Zeno brothers' voyage was invented. The map was assembled from second-hand sources and creative speculation, and the apparent accuracy of an ice-free Greenland is coincidence. A stylistic choice by a cartographer who did not know what lay beneath the snow and simply drew a coastline as coastlines were drawn. The match between the map and the subglacial terrain is pattern recognition projected backward. The second possibility is the one the fringe will not let go of. The Zeno map preserves, however corrupted by Renaissance retelling, the trace of a source older than the ice itself. A map of a Greenland that had not yet been buried. A map drawn from a world that ended before recorded history began. The phantoms in the North Atlantic, Friesland, Estotland, and unfrozen Greenland refuse to settle. The hoax theory explains the document. It does not entirely explain the document's strangest feature. And somewhere beneath 2 kilometers of compressed glacial time, the rivers the map remembers are still there, frozen mid-flow, waiting to be seen again. Number 1. The Piri Reis map, the document that should not exist. In 1929, archivists working in the Topkapi Palace Library in Istanbul pulled a fragment of gazelle skin parchment from a forgotten collection and found themselves looking at something the historical record could not easily accommodate. The fragment measured approximately 90 by 63 centimeters. It was drawn in rich earth tones, decorated with elaborate ink illustrations of ships cutting across open ocean, animals native to continents the artist had likely never seen, and rulers seated in distant kingdoms. In the margin, the cartographer had signed his work and dated it to 1513. His name was Piri Reis, an admiral of the Ottoman fleet, a navigator who had spent his life on the Mediterranean and the Aegean, and who had compiled this map, according to his own annotations, from roughly 20 older source maps. Some of those sources, he claimed, dated to the time of Alexander the Great. What survived was only a fragment. The complete map, whatever it had originally depicted, has been lost. But the fragment alone was enough to start a controversy that has not ended in nearly a century. The map shows the coastlines of South America and Africa with a precision that, for 1513, is already remarkable. The relative positions of the continents, the contours of the Brazilian coast, the western bulge of Africa, these were drawn just 21 years after Columbus crossed the Atlantic, decades before European cartographers had systematically charted the South American interior. Piri Reis was working from sources, and the sources were good. That alone would make the map a significant artifact in the history of cartography. But it is the southern edge of the fragment that turned the Piri Reis map into something more than an artifact. Below the southern tip of South America, the coastline continues. It bends eastward. It extends across the bottom of the parchment in a long, complex shoreline marked with bays and inlets. And in 1956, an American history professor named Charles Hapgood looked at that coastline and made a claim that has haunted every conversation about the map ever since. Hapgood argued that the southern coast on the Piri Reis map was Antarctica. Not Antarctica as it appears today, buried beneath 2 kilometers of ice. Antarctica as it exists beneath the ice. The subglacial topography. The bedrock coastline that no human eye has ever seen, and no surface survey can detect without seismic instruments and ice-penetrating radar. Antarctica was not officially discovered until 1820. The first systematic mapping of its subglacial topography did not occur until the International Geophysical Year of 1957 and 1958, more than 4 centuries after Piri Reis signed his fragment of gazelle skin. The implication of Hapgood's claim was that someone, somewhere, at some point in deep antiquity, had mapped a continent before it was buried in ice, and that map, copied and recopied across millennia, had eventually reached the desk of an Ottoman admiral in 1513. The mainstream cartographic response is firm and worth stating plainly. Most cartographers identify the southern coastline on the Piri Reis map as a distorted rendering of the South American coast, bent eastward to fit the parchment, compressed by the projection Piri Reis was working with, and shaped by the limitations of his sources. The bays Hapgood matched to sub-ice Antarctic features can be matched, with similar confidence, to inlets along the Argentine and Chilean coasts. The fragment is not proof of a vanished civilization with global mapping capability. It is, by the standard reading, a brilliant Renaissance compilation that has been overinterpreted for 70 years. That is the mainstream reading. It is probably correct. And yet, the Piri Reis map persists in the imagination because the mainstream reading does not entirely dissolve the strangeness. Piri Reis was not inventing his coastlines. He was copying them from sources he named, sources that included charts attributed to figures from antiquity, sources that have not survived. Whatever those 20 older maps contained, whatever knowledge had accumulated in the libraries of Alexandria and Constantinople and the Arab world before being scattered by fire and conquest, Piri Reis was the inheritor of a tradition we can no longer fully reconstruct. The fragment in Istanbul is a window into a lost archive. The original maps are gone. The civilizations that produced them have left only their reflections, copied through intermediaries, surviving by accident on a piece of gazelle skin that someone forgot in a palace library for 400 years. What makes the Piri Reis map the apex of this list is not the claim that it depicts Antarctica. It is the certainty that it depicts something we have lost. The sources Piri Reis named were real to him. They were sitting on shelves. They were considered authoritative enough to compile from. And every one of them has vanished. The map is a fragment of a fragment, the last visible trace of a body of cartographic knowledge that the world has otherwise forgotten existed. The original is still in Istanbul. It is kept in climate-controlled conditions, displayed rarely, studied continuously, argued over endlessly. The southern coastline still bends eastward across the bottom of the parchment. The ships still sail. The rulers still sit in their distant kingdoms. And the sources Piri Reis copied from, whatever they were, wherever they came from, whoever drew them first, remain exactly where they have been for 5 centuries. Gone. 10 maps. 17,000 years of human hands pressing knowledge into stone, plaster, bark, parchment, and skin. From the manganese dots above the bulls at Lascaux to the gazelle hide that Piri Reis stitched together in an Ottoman workshop, the span between the first and last artifact on this list is longer than the entire history of agriculture, longer than the history of writing, longer than the history of every empire that has ever risen and fallen. And yet a pattern threads through them. Each of these objects, in its own way, depicts something its maker should not have been able to see. A land bridge between Siberia and Alaska that drowned beneath the Bering Sea 10,000 years before any Ottoman cartographer was born. A subglacial Antarctic geography that would not be confirmed until seismic surveys penetrated the ice in the 20th century. A Greenland without its ice cap. A river network in Bronze Age Brittany rendered with 80% accuracy across an 18-mile territory. Constellations tracked from the floor of a Paleolithic cave. The conventional explanations are real. Coincidence? Distortion. Speculative continents that happen to align with later discoveries. Hoaxes elevated by wishful interpretation. Each artifact, examined alone, can be folded back into the standard timeline with enough effort. But the artifacts do not exist alone. They sit in museums in Istanbul, in archives in Paris, on rock faces in the Italian Alps, on cave walls in the Dordogne, in storage rooms in Brittany where a Bronze Age slab waited 114 years for someone to recognize what it was. They are cataloged. They are photographed. They are dated by methods that do not lie. And together they describe a species that was watching the world more carefully and for longer than the official chronology permits. Whether the explanation is lost civilizations, transmitted knowledge across generations we cannot name, or simply that human beings have always been more observant than we give our ancestors credit for, the conclusion bends in the same direction. The map of human history is not finished. The coastlines are still being redrawn. The interior is still mostly blank. The people who carved Bedolina, who painted Çatalhöyük, who shaped the Saint-Bélec slab, who compiled the sources behind Piri Reis, they are gone. Their languages are gone. Their reasons are gone. What remains is the stone, the pigment, the ink, and the quiet, persistent suggestion that we arrived later than we think to a world that had already been measured. If you want to see more videos like this, click the video on screen now and make sure to subscribe.